the WhatsApp chat. So if you want to join the WhatsApp group, the link to the chat is in the chat. Also, please use on screen. You can WhatsApp me on 083-790-8387. I will add you to the group, or you can email me. So after this session, later this evening, I will share the presentation, and hopefully 2 presentations and the recording as well. Okay, so tonight gonna try to do 2 sessions so that or 2 chapters so that we can catch up a bit. So firstly, gonna start looking at basic operations. Just going to go through a bit of theory, then going into some previous assignment questions, previous exam questions, and then I also want to get to chapter 3, where we're looking at some more operations around factors, fractions, decimals, and those kind of things, so that next week, hopefully, we can also then get to hopefully measurements and maybe expressions, so that we might do chapter 4 and 5 next week, so that we can just quickly catch up with where you need to be when you need to do your next set of assignments. Okay, so basically looking at operations, so going to look at basic operations on numbers and variables, then into powers and roots, and then nearly looking at a combination of all of that in some operations that you need to perform. So then we will need to look at the order of the operations, what you do first, what you can cancel out, what you can't cancel out, and that is how we will then look at the basic operations. So also to note that this is, remember, your assignments and exam is open book, so you are allowed to use all the notes and presentations and all of those things, and closer to the exam I will also share a 1-pager formula page that I have created for all of the chapters, so I will definitely share that with you as well. Okay, so we basically, when we look at operations, we're gonna look at subtracting, addition, multiplication, and division. It might be to do with fractions that comes in the next chapter. It might be to do with whole numbers. It might be that we introduce numbers with exponents. It might be that we need to do it with variables. So one thing I just want, and also if you Google it, you will see that sometimes they use different naming conventions, but I just wanted to show this nearly so that if they do give you a theory question or give you a question to say, what is the 7 called in this expression, or what is the n called, or what is the plus called, or what is the 2 called, that you can mention it, Um, I haven't seen a lot of the theory questions, but it sometimes does come up. Um, so nearly just if it's more precaution than anything else that we're looking at it. So that if they ask something like this in the assignments or in the exam, you have at least a reference point. So the coefficient is the number in front of a variable. The n is the variable. So a lot of times we will look at x, y, a of b is the most likely ones that they will give us in expressions or in formulas. Then the operation is basically that operation that we looked at previously, plus, minus, division or multiplication, and the constant is if there's a number on its own without the variable. Okay, so just if they are something like this as a theoretical question, you have it. And also just again, it is in the study guide, but just when we look at powers, um, and again more on the theoretical side, if they want to to ask a question on what is the 5 that we know that's the base, and to the power of the 3 is the exponent. So again, they might mix up the two slides and ask you which one is correct or incorrect or something like that. So I just wanted to share these two so that you at least have it, and you don't need to look for it. If I ask it in your study guide, you have it on a slide. Then what I also thought is important is just to they talk about exponents, and sometimes in the textbook or sorry in the study guide there's reference to the exponents and then one or two rules. So I just wanted to include for you guys all the exponent rules, the ones that are really critical that we will use a few times is the zero exponent rule. So basically, anything to the power of zero will give you one. Okay, so that's a rule that we do see a lot, and even in the later chapters, we will see a lot of those zero exponent rules coming through. So I think that one is quite important. Then what's also important nearly is when you look at these two, the power rule and the product rule. And why that is important is what we will see is not a lot of times that they will give it as symbols or as variables like this, but what I've seen a lot is that they love to do things like this, where they say 2 to the power of 2, and then in brackets to the power of 3. Or they might do something like 2 times 3 to the power of 2. Okay, so that is more things that they love to ask instead of all the variables and things like that. So and we will go through a whole lot of examples of that, where we're gonna use the exponent rules, and whichever one is needed, we will definitely look at that. And what I've also included is just a simple example on a root, so that we have a exponent, so to the power of, and then we also need to look at roots. They most likely, you will get the square root. So when there is nothing in this, it is basically referencing to 2, and we call it the square root. The other one that they might also give you is the cubic root, but they can give you nearly any kind of root to work with. And what I wanted to show you guys just on this, so we've got now an explanation here of how they do it, but let me show you just another way to look at it. Because here they went into say, okay, but we can break 36 up as 6 to the power of 2. We can break x to the power of 8 up to say x to the power of 4, and then to the power of 2. But how I normally look at this is to say, okay, we've got to the power of 2. There goes my screen. Let me just make it bigger again. Let me just rewrite this. Okay, so we've got 36 x to the power of 8, and that we take the square root from. So what the first thing I would also do is to say, okay, so let's see how we can simplify it. So yes, 6 to the power of 2 gives you 36. And I'm not going to change the 8 at all. So then we still have, let me just make sure that now it doesn't look like an 8. Let me just, don't know why my screen is giving me this problem. Sorry. Cool. Okay, so what we do when we see this to here in, I call it in my bucket. So when I see that two within my bucket, what I'm allowed to do is to say, well, I bring that into the equation so that that bucket or the square root disappears. So then it becomes the original 2 divided by 2, because I bring that bucket in, and then I see that nearly as your, and that is how you can reference or learn it as well. That becomes your division. So 2 divided by 2. Then the same on the 8, 8 divided by 2. So x 8 divided by 2. Sorry about that. I just needed some water. So now one can say, well, 2 divided by 2 is 6 to the power of 1, and 8 divided by 2, 8 divided by 2 is 4, so that becomes x to the power of 4. Okay. I will show you a few of these examples. So trust me, I've got enough here that we will work through. We are, when we finally have an exam date for you, we will also make sure that we get enough prep in, that we cover lots of extra questions. So you don't need to worry about that. We will make sure about that. Okay, then the last one before we get to some exercises is just, and you might have seen it in some of the other subjects as well, is what we call BOTMAS. So basically order of operations. The one that, so if you Google it, you might Google BOTMAS, and there's another one which I didn't realize before I worked through the study guide, is sometimes that they call PEMDAS. I remember BOTMAS is just so much easier. So you look at brackets, orders, division, multiplication, addition, subtraction. The other one, yes, it feels to me sometimes some of these words are higher grade. So that's why I love to look at BOTMAS, because easy to explain. And what will happen is also this becomes the most important of the ways that we need to work out some of the problems that we will see. So we will need to look if there's brackets. If there's not brackets, we need to look if there is any order or exponents. If there's none of that, then it's division, multiplication, then addition and subtraction. So definitely a very typical order of things how we will need to do the operations. Okay, so that is just a bit of theory around the basic operations. Again, I will share the presentation on our WhatsApp group. The recording will also be on our WhatsApp group. If you're not yet on the WhatsApp group, there is a link in the chat, and you can click on it. It's supposed to add you automatically to the WhatsApp group. Else you can drop me a message, and I will then add you to the group as well. Okay, so let's go into some practice. So the first one that I put together nearly was to say, okay, let's just start with numbers first. Again, in your assignments that was done, I think they did give you numbers first to simplify. Then there was variables involved as well. In the exam, your exam will be very similar nearly to what is in your assignments, and very similar to what is in your last assignment. That's nearly a mock exam that covers everything. So your exam will be very similar to that. Okay, so look at this one. Let's simplify. Simplification, bottom, so we don't have brackets, we don't have orders, no multiplication, no division in the first one. So basically we can say 13 minus 29 gives me minus 16, minus 16 plus 17 will give me 1. We could have done it a bit differently as well. We could have said, okay, let's get all the pluses together. So there's a plus 13, there's a plus 17. So 13 plus 17 is 50. Let's get all the minuses. That would have been minus 29. And 50 minus 29 would have given you 1. Okay, so that's just, and you can use that same approach when the variables are the same. So if some of them had a's with it, you could add the two variables that have the a's together. So you can use it in those different setups. So the next one I nearly wanted to look at, so those two I'm gonna, if we have time tonight, I will come back to that, but I wanted nearly to get into this one, option or question 4. That we just look at question 4, because that again for me is a bit different. So if I look at question 4, so there's a exponent and a bracket. So firstly, we need to do a bracket. So what is inside the bracket? It's 3 minus 6. So 3 minus 6 is minus 3. With the exponent. And then in my other bracket, 5 plus 2 is 7. Okay, so then what is left is the next step is to look at exponents. So minus 3 to the power of 2. And to be safe, I actually will do that on the calculator. So minus 3 to the power of 2 is 9. And the other thing I just want to show you, so it's the same as to say it is minus 3 times minus 3. So minus times a minus will give you a positive. 3 times 3 will give you 9, so the plus 9. Okay, so we have for that first one plus 9, and then minus times the 7 is minus 7. So we don't have any multiplication, we don't have any division. So the next one is adding, subtracting. So plus 9 minus 7 is a positive 2. Plus 2 or positive 2. Okay, so just wanted to show a bit of first brackets, then exponent, and then you do the next step. Okay, so that was just purely simplification. Then we go into a bit of simplification with variables. So all that we have now added is from that first expressions is nearly from a number we've added a variable. So when we have the same variables, so all of them are a's, then we can add all of them together. So then we can say 15a minus 6a is 9a. 9a minus 7a will give you then 2a. Okay, so that is if all of the variables are the same, we can just follow the same procedure. We first look brackets, okay, no brackets, no orders. Then we can basically just do the subtraction. When we have different variables, then we only allowed to add the ones together that are the same. Okay, so we'll get in the next slide or two to what we do if it's multiplication. But first now for adding, we can basically just add the things that are similar. And look at it nearly as a simple way is to say A is for apple, B is for banana. And when you add everything together, you have a number of bananas and you have a number of apples. So 23 plus 4 is 27. So you will have 27b plus 3a. Okay, so we're still not allowed to add the a's and b's together. The same if we were subtracting, we're not allowed to subtract if the variables are not the same. Okay, again, different with multiplication, but we will get to that in the next slide. Okay, so multiplication is now a bit different. So where it was adding, subtracting, only allowed to do with the same variables. Now it's nearly free for all. You can multiply across. So what I normally do is I will first multiply all the numbers out. So, and again, you're allowed to use a calculator, so I go straight to a calculator just not to make a silly mistake. So 13 times 4 is equal to 52. 52 times 3 is equal to 156. 156 times 2 is equal to 312. Okay, so if I multiply the 13 with a 4, with a 3, with a 2, I get 312. And then what I do, the next step is to say, okay, let's multiply all the others. So we've got the A there, we've got the B here, we've got the C here, and we've got another A there. Okay, so that is your answer, but that's not the simplest way of putting the answer together. They want the simplest way. So with the simplest way, they want you to say, but there's one A, there's another A, so we have two of them. There's one B and there's one C. Okay, so that would have then been your final answer. So first do expressions of expressions, do the numbers part first and the variables second. I just quickly want to check. Okay, so I have included some of the questions from a previous exam paper because again, the reason why I start with certain things first is, again, you will write multiple choice, your exam, so you can sometimes already by just multiplying certain things out, cancel out certain answers. Okay, so we will get the last two with some nice examples on study unit 2 or chapter 2 that was from previous exam papers. Okay, then just I've added the exponent rules so that we can just have a bit of a view on it when we do it. And again, please remember it is open book. You are allowed to have it. Actually, the formula sheet that I have created for you guys, I'll share it next week when you have it. Also have these rules and things on it. So I will definitely share it sometime next week that you all have that. I will share it on the WhatsApp group. Okay, so let's look at simplification. So again, multiply, multiply, multiply. So when it's multiplication, we can use the exponent rule. So let's look first. Want to look at this A and this A. So actually we have A to the power of 3 times A to the power minus 1. Okay, so, and then we've got B to the power of 2 times B to the power of 4. Okay, so look at when we have A times A times A, what can we say? M plus N. So where's for A? So we can say it's 3 minus 1. There's for B, and what we can say, 2 plus 4. So 3 minus 1 is A to the power of 2, and 2 plus 2 plus 4 is B to the power of 6. Okay, so by using the exponent rules, we were able to simplify this to the final answer. Okay, so again, remember you are allowed to use your notes, these notes that I will share with a recording on the WhatsApp group. So don't worry, I will share it. All of these notes will also be posted on my UNISA, the Western Cape portal, so that you can get access to it that way as well. Okay, then I want to show you question 3. So here suddenly we work with a division. Yeah, division. So look at this one. So A to the power of M divided by A to the power of N. And what that did was to say A M minus N. Okay, so that is nearly what that rule is saying. So we can say, okay, B is my A, we just call it P. That is actually 3 minus 2. And 3 minus 2 is 1. So P to the power of 1 is just P. Okay, so that is another way that I just wanted to show you, where sometimes we look at the rules and they look very difficult, but when we practical use it, it does become a bit more clearer and does make a bit more sense. Yes, I see a hand. Please ask.
Okay, so I just wanted to ask rather, that a to the power of m minus n, uh, where where did you get that? Oh,
Okay, so this
what?
is straight from this quotient rule. So I just first copied that rule over so that I can use that rule. Okay, so that rule, it just comes straight from that one. So what I try to identify is when we have p to the power of 3 divided by p to the power of 2, which one of these rules will I use? So I looked at it and I said, okay, I'm going to use that rule. But
Oh, oh,
then I just wrote it down so to make it easier for myself. Um, and and that is what you guys can also do is remember you're going to write like you're doing your assignments at the moment. That is how your exam is also going to be. It's going to be online. It's going to be multiple choice. So when I share the formula page with you guys, you can actually, I've written some notes on it as well, but you can then use that and just write that down and then replace it with the numbers you need to replace it with. That's in the question,
oh,
just to
oh,
make it
okay, I
easier.
understand.
Cool.
Another, sorry, sir.
Yes,
So
no,
we
ask,
can
please ask.
we can use in any variable when is the division. So we can use this formula.
Yes, yes.
Okay. Okay. Thank you very much, sir.
Cool. Please, when there's a question, please ask. That's why I'm here. It is, we want to make 100% sure you guys, when we get to the exam, you can do it. Okay, so let's look at some examples from previous papers. Um, and that's why I nearly want to show you guys sometimes. So the previous ones we now needed to work out, there wasn't answers, but there's certain things that sometimes how we work it out, we can start eliminating some answers. So let's look at this. So we need to simplify this expression. So because it is pluses between everything, that means we can only add the things that have the same variables together. If it was multiplication, we could have multiplied everything together, but because we have the add all the terms together, sorry, let me just move that to under the plus sign. So because we're adding, we are only allowed to add the things that are similar. So the easiest for me always is to say, okay, let's find the constants. So let's first find the constants. So now there's a x, y, there's a x. Here's a plus 1. There's a constant that I can work with, plus 1. No, that's a x and a y, so there's the variable x, y, that's variables. Here's another constant, and that's a y, x, so don't want to see that yet. So if I say 1 plus 2, so that one and that one, 1 plus 2 is equal to 3. And so Then I start looking at my option sets and I'm like, okay, here's a plus 3. So that might be one of my answers. Oh, yes, not a plus 3. So let's eliminate. Okay, there's a plus 3, so it might be one of my answers. There's a plus 3. Okay, so at least already I know if I now need to guess, I guess between 3 and not between 4. Then I'm like, okay, so constants done. Then I start at the first variable. Okay, so we've got xy. So let's see where else is there xy. No, this x to the power of 2, so not. Okay, there's y to the power of 2, so we can't do that. X to the power of 2, not. But here is a yx, xy is exactly the same. So there we have another one. So xy plus xy is 2xy. Okay, so then I go through the same. Let's quickly check. 2xy, so that's still fine. xy, xy. Okay, so nowhere there we have the xy. So eliminating already without even doing all of it. And there is a 2xy. So at the moment between option 1 and 4. Okay, so then let's do the second or the third term is plus 3x to the power of 2y. So I'm just checking everywhere x to the power of 2, so not there. Okay, x to the power of 2 with y. So there's one of them, there's 3 of them, so in total there's 4. So 4x to the power of 2 with a y. Oh, let me again just x to the power of 2y. So 4x to the power of 2y. Great, there we have it. Okay, 6. Okay, so that one is incorrect. So then we know option 1 is the correct one. Even with doing everything, we actually have sorted it out. But let's just see. So what is we still need to add is the plus 2xy to the power of 2. And then if we look here, it is 2xy to the power of 2. So we know it is then correct. Okay, but by eliminating the options, it does make it a bit simpler to get to that final answer. Okay, so I want to do the same with question 11. So in question 11, the only difference now is we're not adding, it's all multiplication, and then there is a square root in it. Okay, so let's do it like we did that previous example of a few slides ago. So remember, here is if there's nothing, it actually means square root. So there's a hidden 2. So 36 we know is 6 to the power of 2. And then let's just rewrite a to the power of 16, b to the power of 36. Okay, so we can say we remember, so I just want to bring that back. I use that as a division line nearly. So we can say we take away the square root, but when it is 2 divided by 2, 16 divided by 2, and then 36 divided by 2. And so the first component, 6 to the power of 2 divided by 2, that is 1. So we've got 6 as our number. So let's look at, okay, there's 6, there's 6, 18, no, 18, no. So for now, again, only 2 options that is valid. A 16 divided by 2 is 8. So let's look. A8, A4. So already we know that 1 is going to be our answer that we're looking for. But let's just check. So B 36 divided by 2 is 18. So there we have B to the power of 18. Okay, so again, breaking it up in a bit smaller steps, it makes it easier to understand as well, but also it makes it then easier to eliminate some of your options as well, because again, you're writing multiple choice in the exam, so you can nearly start eliminating some of those options. Okay, so let's look at the last examples of this study unit, and then we'll start and finish also tonight's chapter, I think chapter 3. So let me quickly check. Yeah, we will do factors and fractions and those kind of things as well. So again, we look at simplification. We're going to look at it a bit differently as well. So first, there's brackets. Okay, we can't add or subtract when it's not the same. So next step is to multiply in. So we will need to multiply that into the bracket, but then we will need to multiply that in with a second term as well. And then we're going to do exactly the same with the minus 8. We will multiply that in with the first term, and we will multiply that in with the second term. Okay, so let me just quickly do that and show you. So 2y to the power of 2 multiply with x. So we'll always write the x first, y to the power of 2. So that is 2y 2 times x. Then multiply the other one. So 2y to the power of 2 times minus 1 is minus 2y to the power of 2. So that first term we've done. Then we do the second one. So minus 8x times y to the power of 2 is minus 8x y to the power of 2. And then minus 8x times plus 1 is minus 8x. Okay, so again, now I start looking, is there any constants? No. Then is there all the x's? So there's just this component of x's, so minus 8x. So let's go through all of them. So that's a minus 8x. So happy with that. Minus 8x. Happy with this one so far. Plus 8x. Now it needs to be minus 8x. So I discard that one. Minus x. Sorry, I need minus 8x. So just by first looking at minus 8x, I could have eliminated two of the options already. Okay, so let's look at another one that is just one component. So minus 2y to the power of 2. So let's look. Okay, yeah, minus 2y to the power of 2. So happy that can still be. And here also minus 2y to the power of 2. So both of them still relevant. Let's look at the other one and let's just write them next to one another. We can just make 100% sure. So 2x y to the power of 2 minus 8x also y to the power of 2. Okay, so exactly the same. There's the x, there's the x, there's the y2, there's the y2. So we know that the variables are the same. So then we can just say 2 minus 8, which will be minus 6x y to the power of 2. Okay, so let's look for that. So, oh, okay, this one is not like that. Minus 6xy to the power of 2. There we have it. So option 2 is the one that I'm looking for. So again, nearly following a bit of a process where we can get to that final answer. And then I also want us to look at question 13, because this is also something that you might have gotten already. If not, it might be something that you might get in the exam. So when we look at the exponents and we say to the power of, so let's first work out this. So what we have here is 3ab to the power of 2, c to the power of 3, all of that in brackets to the power of 2. So what I sometimes do to make it easier for myself is I write down actually what they want me to do. So they said 3ab to the power of 2, c to the power of 3, and that we actually multiply by itself. So that is actually what we are doing. So instead of sometimes making a mistake now with, do we say 2 times 2 or 2 plus 2, it's easier to do it this way. So then we can see what we are supposed to do. Then we have divide by AB, and then multiply, and here we only multiply by 2A 3B4. So there's no brackets to the power of 2. There was just brackets there, but nothing else. So let's first do these two. So 3 times 3 is 9. If there's nothing, it's actually A1. So A1 plus 1 is A to the power of 2. B2 plus 2 is B4. And then C is 3 plus 3 is 6. Then let's just put all the multiplications together. So that is 2A3B to the power of 4. And then there is a division, so divide by AB. So let's just rewrite it as they say it so that we can work with that. Okay, so firstly, again, what I will do is I will look at my numbers. So before I go into the A, B, C's and the divide by AB, 9 times 2 is 18. So let's look at, okay, so not option 1 because that's 6. Option 2 might be, not option 3, option 4 might be. So already by just looking at the numbers, we said 2 options are not possible. Okay, so then let's say A to the power of 2 times A to the power of 3. So that is A to the power of 5. B4 is B8. And then we have C to the power of 6. There's only that one of them. And still remember we divide by AB. Okay, but at the moment, what we can also see at the top is, so we've got the 18 and we've got a C to the power of 6 that is also not at the bottom. So I can look at my answers and see, okay, where is C to the power of 6? Okay, not there. There was one, but that is already wrong. There is. So I can automatically nearly say, but my answer is actually option 4. I haven't looked at A or B yet, but by elimination, the other ones are wrong. Okay, so let's just then look at this answer. I'm just gonna start from here again where we have a bit more space. So we've got 18 A to the power of 5, B to the power of 8, C to the power of 6, and we divide by AB. Okay, so remember where we had P to the power of 3 divide by P to the power of 2. We basically said P3 minus 2. So now we can do the same here. So we say 18. There was 18 to the power of A5. At the bottom, there's a 1. We can say minus 1. The same for the B's. B8 minus 1. And C to the power of 6 stays the same because there are no C's. So we can then simplify and say 5 minus 1 is a to the power of 4. 8 minus 1 is b to the power of 7. And 6 to the power of c to the power of 6 stays c to the power of 6. And so then, just to make 100% sure, it is that number 18, a to the power of 4, b to the power of 7, c to the power of 6. Okay. So a bit of expressions that we need to simplify by using exponents. So they do love to ask this in the assignments, like you guys would have probably seen already. And they love to ask this in the exam as well. Okay, so I'm just quickly gonna stop the recording. Let me see if I can do it. No, it's fine. Let's just continue. So that is the end of basic operations. And I wanted to cover 2 topics tonight, so let's go into the next one as well and see if we can finish that for tonight as well. Again, I will share both presentations with you on the WhatsApp group. I will also share the recording with you, so I will share all of that with you guys. Just want to quickly check what is happening. Okay, so at least this is okay. So chapter 3 delves a bit more into more of the operation. So with chapter 2 was looking at plus, minus, multiplication, division. We did a bit of powers, we did a bit of roots, and then there was questions where
Excuse me,
yes,
sir. Yeah. So can you please repeat that expression that we did? The one
okay,
was x squared, 36 squared to the power a
let
16.
me quickly do that. No worries. That last one. This one. The 36, A16, B36. That one.
Yes, that one, sir.
Okay, cool. Okay, so let me quickly duplicate the slide for you. Let's just so I'm now gonna explain it also a bit differently so that okay, so let's quickly look at this one. So look at it also. So let me explain it a bit differently to the previous. So
Okay.
how we can also look at this is to say it's 36. Why am I? Sorry, let me just make it big again. Okay. And then, so let's first split it up so that okay, so that is nearly the first step. let's split it up so that it is a bit easier to work with, that you don't put everything together. So let's first work now with the numbers. So 36, we know that, and you can put it in your calculator, the square root of 36 is 6. But for us to simplify it, how I look at it is I see this line as a division line. Okay, so we've got 36, so that is 6 to the power of 2. So what I then say, well, that's a division line. So I've actually got 6 to the power of 2 divided by 2. And that answer will be 2 divided by 2 will be 6 to the power of 1, which is 6. Okay, so that is how I would, in actual fact, have done that constant or the number part first. So that out of this, one can say, okay, my answer will be 6, and then something will happen with the A and the B. So if we need to pick between two, those are the two. It's all option 1 or option 2 that we work with. Okay, so then I do the same with the A and the B. So remember, there's a hidden 2 when we look at square roots. So it is A to the power of 16, B to the power of 36. So if I again see it as this line is a division line, I can say it is A 16 divided by 2 and B 36 divided by 2. So then if I have A 16 divided by 2, that gives me 16 divided by 2 will give me A to the power of 8. And then 36 divided by 2 will give me B to the power of 18. And that will then have been option 1. Does that make a bit more sense? Does that help?
So it helps a lot. It
Okay,
helps a lot. Thank you
cool.
very much.
Okay, great. Okay, so let me just quickly, I just want to check something. Okay, cool. Okay, so let's go into fractions, factors, decimals, percentages, and ratios. So chapter 3. So in chapter 3, where they talk about, so they could have combined chapter 2 and 3 together, because again, we're just looking here at a bigger set of operations. So we're going to look at factors. They love to ask things around prime factors. Then they throw in lowest common multiple. So we will look at what that means and what you need to do. Then they might ask questions around certain operations with fractions and decimals. They might ask you to round off. They might ask you to change a fraction into a decimal. and for that, you are allowed to use a calculator. So please don't. You're allowed to use calculators in this subject. So again, allowed to use calculators, allowed to use your study guides, allowed to use your notes. And then we will look at a few examples as well, where we need to look at percentages and ratios. So with the ratios, they might say, you've got a certain amount of money and you need to divide it into a certain ratio between three people. Or they might say, that you need to mix something together, and to make the bread, you need so much baking powder, so much water, so much salt. I'm not making things up, but when in a ratio, they might ask you to say how much is needed for each of them to bake a bread, or to bake 100 breads, or something like that. Um, Then next week, what I'm going to show you guys as well is, and I think they've done it already in your assignments, is where they bring in measurements. Um, and I have seen last semester there is questions where they combine measurements and ratios. So in next week we will focus on measurements, and go into detail around measurements. Okay, so on operations, they might ask you to find the common factors of one factor. So they might ask you to work out what's the factors for one number. They might give you two numbers, and then the question is, what is the lowest common multiple of the two numbers? Okay, so depending on what they want to ask you, it can be one or both of the two. And I have some examples that, again, we will work through. Then and nearly looking at this slide where we have a 36 and a 24. So that is where the least common multiple come in. So they might ask you, okay, you've got the number 12, you've got the number 15, you've got the number 20. What will be the least common multiple for those three numbers? And I know I have questions in there in these options as well. So we will look at the lowest common multiple, and look at questions around that. Okay, and let me quickly see what's the next one. So this one, it is that previous slide, but I just quickly want to show how we're going to do it, so that when we get to some of the questions, it's just going to be, we're just going to repeat it. So we're just going to repeat the process. So how I normally look at it is a bit different to what they did. So, and again, one can Google least common multiples, and there are lots of examples online that you can look at. But how I would have done it is a bit different to them. So I would have said, okay, what number goes into 12? So I would start at 2, and then I know there is 12, or 2 goes into 12 6 times. Then I would have said 2 goes into 6 and 3 times, and then 3 goes into 3 once. So that, yes, I get to the same 2 times 2 times 3. So that would have been my factors for 12. Then I look at my factors for 15. So again, I would first have said, okay, 3 goes into 15 5 times. Then 5 goes into 5 once. So my factors for 15 is 3 and 5. And then the next one, 20, again, I would have said, okay, I always start with the smallest. So 2 goes into 20 in 10 times. 2 goes into 10 in 5 times. So 5 is the only one that's left. So 5 goes into 5 once. So my factors for this would have been 2 times 2 times 5. So what least common multiple means is that I now need to take into account the least factors that are in all of them. So basically, I look at my number 12 and I see, okay, here's 2 twos. Then I look at 15. Okay, there's no 2s, so I don't need to add them. And when I look at 20 and I see, okay, there's 1 and 2, so they are actually covered already by that 1 and 2. Okay, so we don't need to repeat that again. When I go back to my 12, I see, okay, there's a 3, so there's one of them. I go to 15, okay, there's only one of them, so that 3 is already represented by that 3, and there's no 3s in 20, so nothing to add to it. Okay, so 12 is done. When I look at 15, okay, so what's left is a 5. 5 is, so 15 is done, and in 20, there's 1 5, that 5 is represented by that 5 already. So I'm happy that all my factors are now represented by this lowest common multiple. Okay, so that is basically what lowest common multiple means, is that in the end, we look at those three numbers and we will check out of those three numbers what's the minimum factors that we need to get to a 12 or a 15 or a 20. So 2 times 2 times 3 would have given me the 12. 3 times 5 would have given me the 15. And 2 times 2 times 5 would have given me the 20. So that is basically how we have gotten to that least common multiple. So in the examples, what we're going to add to that is, if I now put in variables as well, how we going to then make it simpler by also getting to the least common multiple for the variables. So that will be one of the questions we will go through tonight still. Then the other component that they love to ask. And again, it might have already been in some of your assignments, and they love to ask it in the exam. So again, a very, very important one is when we look at fractions, and they love to call it a proper fraction or improper fraction or a mixed fraction. So where the proper fraction is, like they say here, the numerator is smaller than the denominator. So a 5/6, a 3/4, a 1/2, that is all proper fractions. So, and how I remember it nearly is, it's a proper fraction is how I like to call it a normal fraction. It is a smaller number at the top, a bigger number at the bottom, and it is one fraction. An improper fraction is when your number at the top is bigger than your number at the bottom, so that there is more than one nearly. If they rewrite an improper fraction that you need to have a whole number, then we call it a mixed fraction. So a mixed fraction is basically you've got a whole number with a proper fraction. Okay, so that is what a mixed number is. So they might, in your assignments or in the exam, ask you to rewrite into an improper function, a fraction, or they might say write as a mixed fraction. And that is important because they might, in your answer set, have this number and this number because they want to test you if you know which one is improper and which one is mixed fraction. So they might even have both of them in your answer set, but they want to make sure you know what is the improper fraction and what is a mixed fraction. So just be, again, on the lookout for those words. What I've added here is a bit of nearly a bit of homework and just to play around with a fraction. So again, I will share it so that you can practice a bit just to see if you can get it right, because a lot of these you can see, and let's quickly do one or two of each, so that you can just see what we want to get out of it. So in this first one, we see 5/12 plus 1/12. So 5 plus 1 is 6, and we can do it because it's the same, at the bottom, the same denominator. So 6/12. But basically why they want you to rewrite it is because there is a simpler answer to it. And 6/12, and if you have a Casio or a Sharp, those calculators have nice fraction built into their computers, and you will see that 6/12 is actually 1/2, and that is the simplest form. So they're not going to give you in the exam this whole thing. They're just going to say 5/12 plus 1/12. One answer might be a half, one might be 7/12. So they're not going to show you that there is a way to simplify it. Okay, so they're just going to give you the question with options. So that's why I wanted to show you this one as well. So, or let's look at this one. So 8 over 14 plus 11 over 14. So both are on to 14, so we can have a 14 at the bottom. And then we need to add what is at the top. So 8 plus 11 is 19. Okay, so now we can see here we're sitting with an improper fraction. And I want to write it as a mixed fraction. So 19 over 14, the 19 minus 14 is 5. So I will have 1 as and 5 over 14. And how we can test that again is to say, okay, 14 times 1 is 14. 14 plus 5 will give you the 19. So that's just again a way to really test if you have simplified it correctly. Okay, but here is a lot extra that you can exercise with. Please ask on the WhatsApp group when you're doing this, and there's something you are struggling with. It might be that please just ask on the WhatsApp group, or if you don't want to ask on the WhatsApp group, you have my number. You can ask me on a separate chat as well. But trust me, if any one of you guys are struggling with this, there are other people that are also struggling. So please feel free to ask on our WhatsApp group. Okay, so let's go into firstly a few that doesn't have an answer, and then again here towards the end, I hope. No, so that will be more in our prep. I have lots of these that again have different sets of answers that we need to pick one. Okay, so let's go to the first one. We need to factorize 21. So again, how I look at it is I will always start at the smallest number first. So, okay, 2 doesn't go into 21, but 3 can go into 21. 3 goes into 21 7 times. Okay, so there's not a lot left here. 7 goes into 7 once. So we basically for 21 only have the two factors 3 and 7. Okay, that's not, yeah, that's basically it. So let's rather look at the 72. That is, we'll have, I hope, many more factors. So again, I'll start smallest number first is 2. So 72 divided by 2 gives me 36. Then 2 can go into 36. So 36 divided by 2 is 18. Okay, so 2 can go into there again. So 2 goes into 18 9 times. Okay, then 2 can't go into 9, but 3 can. 3 goes into 9 3 times. 3 goes into 3 once. Okay, so the factor that I'm then working with here is 2 times 2 times 2, and the other component times 3 times 3. So we could have, if we wanted to rewrite it, there's 1, 2, 3, 2. So we can say 2 to the power of 3 times 3 to the power of 2. And that would have given you your answer as well. Okay, so again, I should have actually added some ones that you can see how it is answered in the assignments and the exam, but it might be that both of them are, well, both of them are right. It's just depending on how the answer set looks like. So if they given you in the answers all of the fractions, it's the one that you pick. If I give it to you as exponents, then that's what you pick. They won't give you both. So they won't tell you to factorize and then give you that option and the bottom option, because it is exactly the same. And not one of them is in the simplest form. Both of them are in the simplest form. So they can't do that. So it is nearly basically let that answer set guide you. Okay, lowest common multiple. So lowest common multiple is when we basically looking for the fractions in all three of them. In this instance, we've got three numbers, and then out of that, we need to pick what are the factors that goes into all three of them. So let's pick this one. Feels to me a bit more difficult than the first one. So let's look at that. So we're going to check what is 8. We're going to look at what is 32. And let's hope that was. And we're going to look at 96. And then we will, out of those ones, get what is the lowest common multiple. So for 8, let's start with the smallest. 2 goes into 8 4 times. 2 goes into 4 2 times. And then 2 goes into 2 1 time. So this one is 2 times 2 times 2. Okay, so that is, if we need to get the factors of 8, that is the factors of 8. So let's look at the factors of 32. So again, start at 2. So let me just make this also a bit neater. Okay, so 2 goes into 32 16 times. 2 goes into 16 8. Okay, now we will follow the same pattern. 2 goes into 8 4 times. 2 goes into 4 twice. And then 1 left. So wait, I skip now. 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 2 is 2. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. Okay, so we sit with 2, 2, 2, 2, 2. So that's 5 2s. 2 times 2 times 2. Sure. Times 2 times 2. Okay, and you can test it on your calculator. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Okay, so if we need it for factors for 32, it is 5 2s. Okay, so let's look at 96. So 2 goes into 96 in, what is that, 48 times. 2 goes into 48 24 times. 2 goes into 24 12. 2 goes into 12 6 times. 2 goes into 6 3 times. 3 goes into 3 once. Okay, so again, what we have here, 1 2 3 4 5 5 2s and 1 3. Okay, so then if we need to get the common multiple, let's quickly use a different color. So we've got 1 2 3 in that first one. 1 2 3. And so in the second one, there was for 1 2 3. So we need to add 2 more to have it covered in the second one. So that is 1 2 3 4 5. So in the third one, we've got 1 2 3 4 5. So all the 2's are covered, but we still need the 3. Okay, so that would have then been our lowest common multiple, because we have those 2's covered there. We have the set of 2's covered there, which is also covered there, and then we have the 3 that is covered there as well. So lowest common multiple by only looking at numbers. Okay, so hopefully the next one. Okay, no, so I have lowest common multiple when we are going to do your exam prep, so we will look at that. Okay, improper as a mixed fraction. So mixed fraction but means that it is a whole number plus a proper fraction. So how I look at it is to say 7 minus 5 is 2. So what's left? It's 2 over 5 plus the 1. Okay, and if you multiply it out, 5 times 1 is 5. 5 plus 2 will give you that 7. Okay, so that is a way of looking at it. What you can also do is to say on your calculator, what is 22 divided by 6? So you will see it is 3 comma something. So then we know that it is 3 and it's going to be something over 6. So how I would have worked it out then is to say, well, 3 times or 6 times 3 is 18. 18 plus what gives me 22? Well, 18 plus 4. So 6 times 3 again is 18. 18 plus 4 is 22, and that is over 6. So again, if we needed to move from improper to a mixed fraction, there's the whole number, and there is then the proper fraction component. Okay, but again, use your calculator. You don't need to now think, okay, how many times goes 6 into 22? Use the calculator. You're allowed to use the calculator, so do it. Don't, especially in the exam assignments, one can still get away with it. But if you're in the exam, and you need the points, then please use your calculator to work out something like this, because it will tell you what the whole number is if you say 22 divided by 6. So then you can say, well, I see it's 3,667, but let's then say, okay, what is 3 times 6? 3 times 6 is 18. 22 minus 18 will give me the 4. Okay. So we've done this a bit in chapter 2, but what I want to show with this one is a bit that you can simplify before you work out the numbers. So you can go and say 7 times 15 on your calculator. 7 times 15 is 105. You can go and say 9 times 14 is 126. But now you still need to simplify that fraction. So what I would rather do is to say, okay, so let's look at this. So there's a 7, there's a 14. So 7 can go into 7 once. 7 goes into 14 in twice. Okay, so that becomes a bit easier to work with. Then I look at the 9, I look at the 15. Okay, 3 can go into 9 3 times. 3 can go into 15 5 times. Okay, so now I can do exactly the same. 1 times 5 is 5. 3 times 2 is 6. 5 over 6, and we're going to check now if it is the same as 105 over 126. So 105 divided by 126 is 0,833. If we say 5 divided by 6, it's 0,833. Okay, we could have also done another calculation, is to say, okay, if we look at 105, but I am going to use the calculator. So how many times does 103, because I know 2 can't go into 105. So how many times does 3 go into 105? So 105 divided by 3 is 35. 126 divided by 3 is 42. And so that seems like I can make that still simpler. So what if I say 35 divided by 7? I get 5. 42 divided by 7 is 6. So again, exactly the same answer. And this type of question, they are more likely to have this as your final answer than the 105 over 126. Okay, so this is just an example why it is sometimes important just to make it a bit simpler for yourself by eliminating so that you can get to that final answer that is the most simplified answer. Okay, so let's look at another one. So again, specifically the one where there is a division, and you can look in your study guide as well. So when we have this 7/8 divided by 5/4, what we are allowed to do is to change that. So we are allowed to change the division to multiple, but when we do that, we need to swap the term that is on the right of that. We need to swap around. Okay, so we can do that, but we need to swap it around. So what we would have done here, this bottom one, is I would have written, and you can go and exercise this as well, is I would swap it around. So the number that is on the right of the division, so it becomes multiple. So then I can swap that around to 25/15. Okay, and that is a mathematical rule that you're allowed to use. You don't need to show why you can do it. It is a rule that we're allowed to use. Okay, and then it makes it a bit simpler to now also cancel, because now we can say, okay, well, 4 goes into 4 once, 4 goes into 8 twice. Then 7 times 1 is equal to 7. 2 times 5 is equal to 10. So our answer is 7/10. Okay, so please go and practice or look at question 2. And again, when you guys have a problem with that or need some clarification, please ask on the WhatsApp group. Just as I'm chatting, if you're not part of a WhatsApp group and you are of this WhatsApp group and you might be watching the recording, please go and send me a WhatsApp on 0837908387. I will add you to the group. Okay, we've got about 10 minutes left, so I wanted to do a ratio question, because and we will do both, because they love ratios. Next week, what I am going to do when we look at measurements is I will bring in measurements and ratios together so that we can just see a combination of that as well. Okay, but let's look at these two ratio questions, and that's where we will end off the night. So they tell us there are 15 green apples and 25 red apples in a bowl. Determine the ratio of green apples to red apples. Okay, so this one is a bit more straightforward. They tell us there's 15 green, there's 25 red, and we need to do the ratio as, and let's first write it down, as green, determine the ratio of green apples to red apples. Okay, so they tell us, write it as green to red. So green, there's 15, red, there's 25. It might be that they want it simplified again. So then I look at it and, okay, there's lots of 5. So let's say 5 goes into 15 3 times. 5 goes into 25 5 times. So that would be the ratio of green to red. Okay, so that's a more simpler one, where they tell you you have a bowl with 15 green apples, 25 red apples. But what they could have also said is, you've got 40 apples, and that is split in the ratio 3 to 5. Okay, and then how many green have you and how many red have you? So that's nearly the second question, is around that. So the second question looks at, so they say Jacob's decided to divide his flock of sheep amongst his 3 sons. He has 57,000 sheep that he wants to divide between the 3 sons. So Talbu gets the ratio, or Talbu, Lucas, and Sipo gets the ratio as in 3 to 11 to 5. Okay, so now we will need to say, we need to divide this 57,000 into a ratio 3, 11, and 5. Okay, so bit different. So the first thing I look at is, okay, in how many pieces must we divide this? So we've got the 3 sons, but how many pieces are there? So there is 3 plus 11 is 14 plus 5. So there's in total 19 pieces that we will need to divide the 57,000 in. Tabu gets it, he gets 3 out of the 19. Lucas gets 11 of the 19. And Sipo gets 5 out of the 19. Okay, so if we again add 3 plus 11 plus 5, we do get the 19 in total. So how I then would work it out is to say, okay, 3 divided by 19 times 57,000. That gives me 9,000 for Tabu. Then the 11 for Lucas is 11 divided by 19 times 57,000. And that gives me 33,000 for Lucas. And then the last one, so there is the one that Lucas needed, but let's just check the last one. Sipo, 5 divided by 19 times 57,000 gives us 15,000. So that 57,000 is split on the 9,053 and 15, and we can just check it. So let's just make sure. So 9 plus 33 is, so 9,000 plus 33,000 is 42. 42,000 plus 15,000. So if we add all of those amounts together, we get the 57,000 again. So we then make 100% sure that we actually have divided it according to that ratio. Okay, so that was very quick that we went through the two study units tonight. So we went through basic operations. We went through chapter 3 as well, looking at factors, fractions, ratios. Next week, I think I'm only going to look at measurements, so that we really go into detail with measurements. It might be that, yeah, I want us to make sure that we cover measurements quite thoroughly, because I know they love asking measurements in the assignments and in the exam. So I think next week the big focus will be on measurement. If we have a bit extra time, we'll look at expressions, but the big focus next week will be on measurements. Okay, so that is it for tonight. I hope it helped. Yeah, not a lot of